invited to talk about our experience in choosing Flink as our streaming framework. So I'm going to talk a little bit also about my experience of the other frameworks that were included in our evaluation, and I hope to give you some insights in these as well, and also why Flink is at the moment so special. I already introduced myself. I work at the Otto Group Business Intelligence Department, as well as my colleague Christian, who held a talk earlier in yesterday. And we did this evaluation during April and May. So Flink was still in 0.7 and 0.8. At the end, we are at 0.9. So the evaluation is not up to date anymore. But so I'm going to talk a little bit more about how we did the evaluation instead of how Flink compares to the other frameworks. So this evaluation was done during an internship at the Otto Group, and at the moment I'm writing a master thesis trying to improve the testability of Flink also at the Otto Group, and we're going to publish and open source this tool. So you will be hearing later about some of my findings and some of the things I've implemented, but not in this talk. So let us go right to the... So before doing such an evaluation, you have to have some set of requirements, expectations, criteria that you are expecting from the framework you're going to use. So the first step was to actually collect these things. So in the usability department, we wanted to have a steep learning curve. We wanted to have a good DSL, API, DDL, UI of something kind, a good abstraction layer on top of the framework. Functionality-wise, we wanted to have a really wide selection of operators that we can choose from, that we can build on. So we wanted to also had some aspects on flexibility. We wanted maybe some hot deployment, pipeline redeployment, reconfiguration during the runtime. Also you have your connectivity to other systems you're already running, and on the non-functional requirements case, you will have such things like scaling, fault tolerance, but also latency and throughput. Support-wise, for a company, enterprise support is always nice, so you're looking for that. But we also looked at the community and available documentation. Architecture-wise, you want to have something that fits in your current infrastructure, so nothing too complicated to run, and with not too many dependencies that you're not having already running in your infrastructure. So our rating then was based on research. I looked at white papers, documentation, code, articles, mailing lists, and also discussion boards and something like that. And the true part is you get a lab rat that has to try all these frameworks. So in this case, the lab rat was me, and I actually was a lab rat because we measured how long it took me to implement a use case in all of these frameworks. And the use case was a very basic one. We are getting data from our shops in clickstream form, our WebSocket. Then we are doing some filtering because we are only interested in certain page types. Then we are getting data from different shops, so we want to do these aggregations for each shop. and then we're just aggregating views and aggregating purchases and doing some kind of word count at this point and writing the results into a Kafka topic. So something basic and easy to implement in a wide variety of frameworks. So the list of frameworks we looked at was SQL Stream, Pulsar from eBay, Spooker, which is developed internally, Apache Spark, and Apache Flink. So at this moment you're noticing there is Samza missing and Storm. So we had this this feeling that Storm has a little bit dried out, is not state of the art anymore, so we didn't include it at this point. And Samza is very basic and has a very nice and easy to learn architecture, but the support for windowing was not at our level that we are expecting of the framework. So I'm going to introduce each framework shortly, hopefully. So the first framework we look at SQL Stream. This is an enterprise framework from a company with the same name. They are also named SQL Stream. They are sitting in the USA. And this framework was released in 2003. So it's quite old for a streaming framework. So what they have is this SQL Stream server where you have a catalog of SQL queries and you're running these on a control node against your stream. And on the right side is all the external sources that you can plug in into this server. So this is a single node. This is not so it's not distributable. You have to use a load balancer and Kafka to do that manually. So scaling is not done automatically, so your queries are not distributed in some sort of cluster. But on the other hand, you get some really nice functionality for defining your pipeline. So you can define your statement and you immediately see the results in a workbench that is based on Eclipse, and you're also having a web UI where you're even more interactively can click together your statements and see immediately how they changing your stream. So obviously you have to apply some kind of schema to your stream to get them into the system. And this is actually the abstraction layer. So the kind of abstraction for our use case. So at first you have to define a source. These are all these nodes are SQL statements. So you have an SQL statement named jar, you have an SQL statement named function, and so on and so on. And you have to define them bit by bit and also define your schemas and like so. For the whole, this is all SQL statements you need to run the use case. Something that can be noted at this point are these pumps. These pumps are actually used to generate pressure to stream your records through this through the system. So if you're what was kind of unexpected. So when you're looking at the view, your records are arriving, but when you immediately try to connect the stream to the view, you need a pump to generate this pressure. This is some kind unique. I've never seen this in another framework, so that you explicitly have to shuffle or do some kind of pressure into your pipeline manually. This is quite complicated. It's not so easy to know beforehand when you have to use a pump and when not. So this is how a window aggregation in SQL Stream looks like. This is for a tumbling window, and this is actually this is how you would do an aggregation in vanilla SQL over time window. So for rolling windows, there is some syntactic sugar, but for tumbling windows, you have to do it manually by hand. So what SQL Stream at the moment is lacking is the scalability that you are expecting from a modern framework, but they are working on it, and maybe they come up with something nice. So the next thing we looked at is Pulsar. This is done by eBay and also released early this year. Pulsar, you have these Jetstream application containers that are running independently, decentralized, so there is no central manager or something central that orchestrates your pipeline. You have these to start by hand. They are shipped via Docker, and then you can connect them in. So you're just configuring the output channel and the input channel to listen to the same topic, and they are connected at this point. The clue at this point is that you can change the configuration of these containers at runtime. So you can change your whole topology of your stream without restarting or stopping your stream. You can also rewire the processors internally in this application containers, and you also can hot deploy SQL statements into these processors. So what they're using for these SQL statements is the Esper processor. This is a complex event processor. It's also quite around for some time. I don't know if anybody has worked with it before, but basically it does the same thing that is done in SQL Stream. You run an SQL statement against the records in your stream. So you also have to use a schema in this framework. So this, so at first I built a source, and then I built two another Jetstream apps that do the actual aggregation, and I've defined all the logic in SQL for this use case. So the SQL looks like this. You define this context. This is your window. Then you use these contexts and doing the actual aggregation on this context. So I think it's a quite nice framework. So the idea is quite nice, but you're lacking a central definition of your pipeline. You somehow have to manage your pipeline is defined implicitly by your nodes itself. So you're losing some kind of overview over your pipeline if you're not managing this very strictly. So I think the problem at this point is that you need some kind of central pipeline definition on which you can work. The next is Spooker. Spooker was introduced earlier also by my colleagues, so I'm going to talk very briefly about it. The idea is to separate code initiation and code deployment and pipeline initiation. What you're doing, so the use case looks like this. Spooker is somehow specialized for this. We are using also Esper in our operators to do the aggregation. So you have a filter for your JSONs, and then you're doing the operation and writing them out to Kafka. And so what you're seeing here is vanilla Esper. Pulsar changed the syntax a little bit. So this is how you're doing windowing in vanilla Esper. The point at this moment is that we are not working on Spooker anymore because we switched to Flink. So what the problem was that we had several big big points to work on to really support all these functionality that we wanted to implement, and now we are trying to port some functionality from Spooker into Flink, as you've heard maybe earlier. So the next thing is maybe at the moment the big player in this field for some kind of reason. This is Apache Spark. The architecture should be familiar because it's quite similar to the architecture of Flink. The use case is done by this API, where I do some filtering, some grouping, and then actually do reduce by key and window, join these and write this out to your Kafka. And the aggregation in Apache Spark looks like this. So the thing to note is at this point you have to consider the size of your micro batches. So the time of these windows has to be a multiple of this micro batches. So when you're actually presenting this to someone and they say, that's not a big problem. I make my micro batches maybe 2 seconds or 1 second, so I have enough room for defining my windows. But when you're actually working on use cases, you want to have windows that trigger by event or that trigger by some kind of other arbitrary requirement that you have. And to do this in Spark, so the next question is, can I do this in Spark? So probably, mostly you can do this in Spark, but you have to do it yourself. You have to do it in some kind of twisted workaround way that you will also have to test yourself in maybe manual end-to-end tests. So you're trying to look if the mechanism you've built is actually working. Then you're deploying this and you're hoping that not some kind of anomaly in your stream or some kind of side effect when running this in parallel on the cluster is breaking your mechanism. So I've actually done something like this in Spark, trying to improve the windowing, and you're really not having any. You're not very confident in what you've built at the end, and you're not really want to run this thing in production. So the question is like, can I teach my cat how to bark? Probably, but maybe you should have gotten a dog in the first place to watch your home. So I'm not really convinced about the future of Spark in the streaming environment, especially if you have these. If you want to do kappa, you need to have consistency, and you're not having the room for I'm doing arbitrary windows on processing time. You want to have this right, and you want it to have you have to have this right in the first place. So Apache Flink, I'm not going to talk much about this. So you're also, at this point, you're also very familiar with the architecture. The use case is very similar to Spark, and the aggregation, it looks a little bit nicer than in the other frameworks. So then we are actually try to get some results of our evaluation and of the time I've spent with all these frameworks and documentation and so on. And the first thing is we try to evaluate what I've done during the hands-on time, during implementing the use cases. So this is the time it took me to build a use case in a framework. So Pulsar.io took me, maybe the logic took me a day, because I was not very familiar with SQL in streams. But then I've failed to get the messaging working inside the framework. So the problem was inconsistencies between documentation, example code, and the demo they're providing. So I really did not set one flag that was missing, and it took me 3 or 4 days to find this little flag. It was really quite frustrating. SQL stream was not very, it's not very, the abstraction is not, in my opinion, not high level enough. You're doing some work that the framework should do for you when you're defining these pipelines. And to get, we actually had problems to ship our own connector to the WebSocket into the SQL stream. So this took 3 or 4 days at this point, and we also had to have heavy support from the company itself to get it running. For Spooker, this was my first time using Spooker. So, but there was also at this point some examples where I could build on. So it took me around 8 hours. Then the next thing I've tried was Flink. Also my first time using Flink. So it took me about 1.5 days to get this right. And then I've done Spark, and because I've done all the hard work in Flink, I just had to port my logic from Flink into Spark, and everything was running. So this is why there's this discrepancy between these two numbers. Okay, so in all these frameworks, I've had to add a WebSocket connector, especially for the type of protocol that we're using at this point. So this is the time I've spent with this. And then we actually did fill out some spreadsheet with some numbers. And this is the list of aspects or criteria we had. If you hit me up afterwards, I can provide you with a blank spreadsheet which you can fill out yourself. But this is some summary. So this is we bundled them into topics, and then rated them from 1 to 5 or from 0 to 5, and did some weight on these aspects, which reflects how important these were for our needs. So I've put these numbers into this web diagram, and as you can see here in the connector-wise, SQL stream is really, I would not so far ahead, but they have to, most connectors, they are enterprise software, they have to have this. Deployment-wise, Spark and Flink are a little bit similar, where the configuration for Spark is much easier. From the architectural concepts, Spark and Flink were at this moment pretty similar and are still similar. for our functional requirements, they were at this moment also very similar. Flink had not have support for event time, but I think at this moment Flink is a little bit more ahead of Spark at this point. For usability, we really liked Flink more than Spark and the other frameworks. So Spooker is actually the last in this topic because it has no IPA at this point, so they are naturally ranked worst. So one thing we wanted to have is flexibility. So there, Pulsar is really outstanding from this kind of view, followed by Spooker and SQL Stream. And as you can see, Spark and Flink, there is some work to do, but we already started to improve this aspect in Flink. So these are the final scores that we had at the end of our evaluation. So in the use case, Spark is ahead of Flink because it took me fewer time to implement this. To implement the use case, maybe we should, at this point, we had to do to adjust these numbers a little bit, but we'll took them with a grain of salt. So, and also in our evaluation, Flink is a notch ahead of Spark, but Flink has done in the meantime huge improvements in consistency and in support for windowing. So if I would redo this evaluation at this point, I think the numbers would quite look a little bit different. So what were the learnings? One problem during the evaluation we encountered is that most of these frameworks are under such heavy development that they are changing faster than you're able to evaluate them. And some other thing is, if you're having a really long catalog of criteria, you have to actually look at each framework and try to find out how are they doing in this criteria. So each criteria you add to your evaluation makes it a significant bit longer, and you are adding more and more work to your evaluation. So you should keep your list quite short. From the business department, they really like to see very long and very detailed lists, but it's from our point of view, from the people who develop with these tools and do the operation, it's not so important. We just have to something to show to the business side of our company, and I hope in the future that Flink, or something I like to see, is for Flink to improve in tooling and improve the actual existing libraries, like the machine learning library and the graph library, so we have something to compare with Spark. So when you look at Spark, you see all these nice libraries, and you're trying to use them, and what you actually will encounter is that most of these libraries don't work in streaming at all, or with very limited usability. So for Flink, it's really an opportunity to also support with libraries the streaming part of the framework. and we are actually at Otto Group, we are trying to work on different use cases of tooling. We are not only using Flink, but we are trying to improve it at this point. So I hope you did get some insights and maybe some tips and how a company looks at something like Flink and evaluates it. And at this, so for wrap up, I will say you will only gain from using Flink. You're not missing out features that are present in Spark, because they're all more or less they're comparable in the base features, but Flink brings you a whole set of new features and new functionality on top of that what Spark is offering. So there should be not this much hesitation to switch from Spark to Flink. So this was my presentation. The obligatory we are hiring slide, and if you have any questions, feel free to ask.
Yeah, thanks you for the great presentation. I have actually a couple comments. So maybe it's good to actually enlighten us on this. Did you have any experience before doing the use case when it streaming use case? Because my comment here, assuming if you started implementing the use case using Spark first, and then doing the same use case in Flink, will have this would the time to implement the use case will be different. And second, maybe comment more than a question. I was giving a talk on Flink in Washington, D.C., and somebody asked, do you see a major differentiator when it comes to machine learning, or what do you think about that? So my answer was that definitely MLlib is ahead when it comes to at least the number of algorithms which are implemented. And somebody from the audience, and I think he's here in this conference, I won't name him, he's the expert in machine learning. He told me, don't just focus on the number of algorithms which are being implemented, but also think about the quality of the code, and his assessment, not my assessment, that the quality is not always there. Thank you. So I expect an answer from the first question, and maybe also your take on the second comment. Thank you.
Your first remark was that Flink is actually ahead in machine learning. No. I'm sorry.
Let me say it maybe short. So my first question was, if you implemented your use case starting with Flink first,
and then these numbers would be different.
And then doing it in Spark, will this have been different? So that's my first part. So my second part. So this the second part was what's your take in like considering the quality with which algorithms are implemented, not maybe just the number, because definitely there is no doubt that the Flink ML implemented a lot of algorithms, but I'm not expert in machine learning. And somebody who is expert and he's attending this conference told me the quality is not always there. So his advice was to think about the quality and the quantity. Yeah, thank you.
So for your first question, I did all the learning experience I did in Flink, and then I just had to apply it in Spark. So that's I already mentioned it. This is why these numbers are this different. But I also learned from other frameworks, from step to step, from framework to framework. I learned more and more about the particular things you have to look for when streaming things. So I think these numbers are we at the beginning we thought we'll look at these numbers and maybe we learn something from it, but they are maybe we should have defined them in another way. This is not done optimally to compare these. So yeah. And the second is about the quality of the machine learning library. So this is something Flink has to carry out to the world. So I'm not a machine learning guy. Also, we did not look at machine learning for our streaming evaluation. So I'm no expert in this. So I've just looked at a list of operations that are supported, and this is maybe what a standard user does to compare these things. This is a problem, and for Flink at this moment, because the user has also this feeling I'm missing some functionality out that I'm getting in Spark. So this is from a user perspective, I'd like to see an increase in supported operations without having the expertise to actually see how the quality is in Spark or how the quality is in Flink. Any additional questions?
Was there any of your use cases low latency was a criteria? For example, if you are building a fraud detection.
Sorry, I can't hear you.
Is there any of your use cases low latency was a high criteria? Because I didn't see any evaluation on low latency or throughput in your.
I did a benchmark of all of these frameworks, but it's not representative in any way. It's not good for comparing them. We are having running around 40 web shops in the background. In the future, we'll scale up to 100 that are bringing in data into our streaming framework. But at this point, we won't get problems with throughput with any of these frameworks. So this was not a core requirement for us, a high throughput. We looked more for functionality and ease of use.
Okay, so because if I understand correctly, one of the major plus point for Flink is low latency compared to sparse streaming. So
yeah,
that was not
you have this inherent latency in Spark. That's right, and that's also something you see at our benchmarks. But in reality, we're waiting for 3 or 5 seconds until these records arrive from our vendor, from the provider, and then to add 2 seconds or something is not highly relevant for us at the use cases we have at the moment. At the future, it can become critical, these 2 seconds, and it was some kind of that. Also some aspect that drove us away from Spark, but it was not something critical that we couldn't have handled otherwise.
Thank you.
No, I will just do it.
You mentioned that Spark and Flink are the worst in the flexibility part, and can you tell us a little bit more how you define this flexibility? And you said you are working on something to optimize flexibility for Flink. And what are you exactly doing for this?
The flexibility is defined in how long it takes you to develop a pipeline and to actually get it running in your cluster. So we actually have to develop these things, package, upload them into our repository, then build them using a Jenkins, and then go to the actual machine and put them into our cluster. So this takes quite long from development to actually running a job. So we're trying to improve this this time, and so what we are looking into is directly sending our jars from sending our jobs or our jars directly from an external tool into Flink via the Akka API that the job manager is providing, and also to have immediately see some monitoring or some results from these jobs you're starting. So the feedback loop of developing and running is shortened.
Hello, thanks for your nice talk, and I have both one question, one suggestion. Is your talk or your evaluation of the frameworks somewhere transparent online that we can read it afterwards, or? And the second is you mentioned the testing framework. And you said, yeah, it will be soon available. And when is soon? This year, next year, the year after?
Yeah, it's always as soon as possible. It's in its early stages at the moment. The source code is public, but there's no documentation at this point. I'm working on this in the context of my master thesis, so I have to actually write my master thesis in parallel to this. So I'm not sure how many things that I've planned I'm actually have the chance to implement, but at the moment you can use it, but I think maybe 2 months and I've polished the API for defining your expectations. So I want to have a really nice API for defining your expectations for your tests. So this is some kind of my main goal of this work, to have an API, to have a way to define expectations you have from a streaming job where you're dealing with non-determinism and unordered output and such things. So I'm working on it. I'm not really sure when it's going to be in a stage where it's usable by the community. But yeah. I'm looking for an opportunity to present it and to present the process I'm trying to implement, to present the process, and maybe to show some prototype or early stages of this. And I think I also need to look into the release of the 0.10 release, so I need to rework some things. So maybe when the 0.10 release is done, then a month or 2 months later, the first version will be available.
Okay,
hopefully.
Sounds good. And is the evaluation of the frameworks available somewhere online?
The slides will be available. I don't know which numbers I'm allowed really to publish at this. So there is. If I'm going to, I don't think the whole evaluation will be available online, but some numbers maybe, because it's really outdated at this point. What is my main concern? It doesn't reflect the status of the status the frameworks are currently in. Yeah.
I just would like to add something to the last sentence. Before I said this, I do work for the Otto Group. He's a colleague of mine, and so what we cannot do is present the numbers as he just said, but what we can do is provide in-depth insight into what we evaluated and how we evaluated that, and so that you have a rough understanding of how we did this, and maybe give you a template or blueprint how to do something similar on your own. And so I think that we can do this pretty soon.
Okay, then thanks for your talk.